to Apocalypse Now, the podcast where we dive into some of the most devastating environmental disasters and explore how we can prevent them from happening again. You've probably heard of the Great Pacific Garbage Patch, and maybe you imagine this giant floating island of trash, like a plastic landfill drifting in the ocean. Sounds super dramatic, right? Like it's full of bottles, bags, junk, tossed by people who couldn't be bothered to recycle. Well, that image isn't exactly true, and in fact, it's kind of a lie. The Great Pacific Garbage Patch isn't what most people think it is, and neither is the story of how it got there or who's really responsible. I'm Holly Stower. I'm an environmental researcher and advisor who's worked with big-name companies to develop sustainable solutions and solve their environmental challenges. I've spent a couple of weeks researching this to outline best what the Great Pacific Garbage Patch is and why it's such a disaster. And trust me, a giant pile of trash is super interesting. So, the Great Pacific Garbage Patch is considered the world's largest accumulation of ocean plastics. It's located in the North Pacific Ocean between Hawaii and California. Cumulatively, it weighs as much as 90 tons, and there is 1.6 million square kilometers of trash, an area larger than the state of Alaska. In 2019, long-distance swimmer Ben LeCompte swam 300 nautical miles across the Great Pacific Garbage Patch, 1 nautical mile for every million tons of plastic being produced each year. In recalling what that swim was like, Ben said, "It's like a fog, or a soup, or a smog. That's what we see with the naked eye. At first I thought I was seeing plankton in the water, the reflection of the sun bouncing off the plankton. Then one day I had a little net in my hand to catch what I thought was the plankton, and I found out it was all plastics. If I'm confused by them, I understand easily that sea life is confused too. We have found plastic in the stomachs of dead fish. We have seen an albatross picking up microplastics on the surface of the water. And we see microplastics embedded in small sea life like jellyfish or plankton. And we've seen whales more than once. 2 days ago, we saw 3 or 4 sperm whales with ghost nets around them. And the most recent time I was in the water, we heard the sounds of the whales right in the midst of the place that had the highest counts of microplastics. We towed a net for 30 minutes and only a very small volume of water went through it. But we counted over 3,000 pieces of microplastics in that sample. The world was first alerted to the existence of the Great Pacific Garbage Patch in 1997 by surfer, scientific researcher and sea captain Charles Moore whilst returning to California from a yacht race in Hawaii. The team decided to take a shortcut as they had spare fuel and came across this huge calm area where everywhere he looked he could see trash, or as he described it, anthropogenic materials. Reflecting on this later and thinking that it could be cleared up or that he could stop it if he only found the source, he endeavoured to do more research on the area. He developed this half-inch mesh net, as what he was seeing was mostly plastic chips bigger than half an inch. This net was then stretched across 2 boats, which collected a large bag of plastic chips. They then sent half this bag of chips to Dr. Curtis Ebsmeyer, an oceanographer who studies flotsam, which is floating wreckage or debris in the sea. The doctor then estimated that the plastic chips were broken from larger objects, explaining that just one 1-litre plastic bottle could disintegrate into so many small pieces that one piece could be placed on every square mile of beach in the world. It then sunk in, the magnitude of the problem for Charles. One, that the origin of these chips was not one source, but from the ocean accumulating the waste, breaking it down in ocean's currents and then spitting it out. And 2, that it was going to be near on impossible to clean up. Unlike natural materials like wood, plastic is engineered to resist decomposition. Instead of breaking down into organic matter that the environment can absorb, it fractures into smaller and smaller pieces, microplastics, and they persist practically indefinitely. The discovery caught the world's attention to ocean plastics, with some crediting the discovery for catalyzing plastic bag bans across the world. Some years later, a 2017 campaign called Trash Aisles sought to draw further attention to the Great Pacific Garbage Patch. So they applied to the United Nations to recognize the Great Pacific Garbage Patch as an official country on World Oceans Day. This is because, under the laws of the United Nations, if the patch was classified as a country, then other countries that had trash that was going into the Great Pacific Garbage Patch, they were required to clean that garbage up. The Trash Aisles campaign was led by Lad Bible and the Plastic Oceans Foundation, and in the weeks that followed sought to achieve the requirements of what it meant for the Great Pacific Garbage Patch to be a country. And they met all the requirements. So first, they established a government. The Trash Aisles used celebrities to accept honorary citizenship, and then they elected them for roles. So, for example, Judi Dench became the Queen of Trash Aisles, and John Cena became the head of defense. Second, define a territory. So the campaign then claimed all of the trash in the Great Pacific Garbage Patch was the territory. Third, to be able to communicate with other states. This helped the campaign's mission. The campaign was all over social media, so that ticked the box. And finally, they brought members of the public to become citizens, and actually ended up gaining more honorary citizens than some real countries, with Al Gore being the first honorary citizen. They also had a currency called debris, as well as a national flag. I'll post some of these on the socials. They're fun. So the Great Pacific Garbage Patch never became a country, but the campaign did a great job of highlighting ocean plastics in international circles. For example, search volumes for plastic pollution went up by about 154% in the 9 months after the launch. So how has the Great Pacific Garbage Patch been formed? So the misconception is that the Great Pacific Garbage Patch is this island of trash. And that very well may have come from the Trash Aisles campaign, as well as any time it's in the media, the images they use are not of the Great Pacific Garbage Patch, or they've been photoshopped, or they're photos taken from locations that are closer to shore. In reality, the Great Pacific Garbage Patch isn't much to look at. It's very much like Ben Lecomte described. It's a murky soup of small plastic fragments. And these microplastics make up about 94% of plastics in the Great Pacific Garbage Patch. And these plastics are there, and they are broken down in two ways. One, by the sun, and two, via ocean currents called gyres. These gyres are large systems of rotating ocean currents. They're naturally occurring, which typically move in a circular pattern, like a slow, very large underwater tornado. So first, how does the sun break down the plastics? So floating plastics are exposed to sunlight, and sunlight brings ultraviolet radiation, UV. This is what causes sunburn, skin cancer, and what plants use to make energy. When exposed to UV, plastics phytodegrade. So plastics are made of long chains of hydrocarbons, so hydrogen and carbon, exactly the same as fossil fuels like coal and oil. The UV breaks the bonds between the hydrogens or the carbons, which connect these chains. And once these bonds are broken, the exposed molecule is then exposed to the oxygen in the air. This is where they react, and this process is called oxidation. And this further accelerates the breakdown of that plastic. This leads to the plastic becoming brittle over time. If you've ever found ocean plastic at the seaside, you may find that you can easily snap it, break it. That has likely been photodegraded and oxidized. So these floating plastics continue to break down into smaller and smaller pieces, into microplastics and then nanoplastics, which is when a nanoplastic is when plastic is 100 times smaller than a human hair. You may be thinking, well, great, plastic is breaking down. Soon it shouldn't be harmful. Once it's a nanoplastic, it means that smaller and smaller organisms will mistake that for food. And I'll talk about how toxins within plastic increase as they move up the food chain. Also, photodegradation and the degradation of plastic takes a really, really long time. Factors such as temperature, the type of plastic, and surface area can impact the rate of these reactions. But putting the long degradation time into perspective, almost all plastic which has ever been produced still exists today, unless it's been recycled or incinerated. So let's talk about the second way these plastics are broken down, with gyres. They are broken into smaller pieces by the gyres physically and then kept in place by the gyres. So there are 5 major gyres in each of the 5 major oceans. The largest is in the North Pacific, where the Great Pacific Garbage Patch is. Then you've got the Southern Pacific Gyre, the North Atlantic Gyre, the South Atlantic, and the Indian Ocean Gyre. So gyres are naturally occurring, formed billions of years before plastic even existed in us. And imagine massive spirals or vortexes of water spreading across thousands of miles. 3 forces cause the circulation of the gyres: global wind patterns, Earth rotation, and land masses. So wind drags on the ocean surface, causing water to move in the direction that the wind is moving. The Earth's rotation then creates resistance, changing the direction of these currents. This resistance and deflection is known as the Coriolis effect, and it changes the surface current angle by about 45 degrees. Then, underneath the surface currents, the Coriolis effect results in what's called an Ekman spiral. While surface currents are deflected by about 45 degrees, each layer, as you go deeper, is deflected slightly less, resulting in this vortex or spiral pattern, the underwater tornado. And this continues to happen until you hit about 100 meters depth, where the forces don't have enough power to create that spiral anymore. In the northern hemisphere, ocean currents are deflected to the right in a clockwise direction, and in the southern hemisphere, ocean currents are deflected to the left in an anti-clockwise direction. And the size of these gyres are determined by the land masses surrounding them. So in general, if there's a lot of space, they will get big. If there's a cheeky continent in the way, then that will restrict the flow. Hence, the Great Pacific Garbage Patch is located in the largest ocean in the world, the Pacific, and is the largest garbage patch of trash. So as trash is dumped into the ocean, or is washed out from beaches and rivers, it reaches these gyres and gets stuck in these vortexes, creating these accumulation zones. And as you may have guessed, each of these major gyres has its own garbage patch. In fact, there are 8 major garbage patches in total. These patches are created very slowly, but trash is drawn into the vortex by the circular motion of these forces, as well as the sun breaking down the plastic over time and creating this plastic soup. And as we produce more trash and more plastic gets dumped into the oceans, these garbage patches are getting bigger. So where does the plastic come from? The mass of the Great Pacific Garbage Patch is estimated to be 100,000 tons, which is equivalent to 800 blue whales or 10 Eiffel Towers. This plastic covers an area of 1.6 million kilometers squared, so that's roughly half the size of the European Union, so it's massive. Over 11 million tons of plastic end up in the ocean every year. 9.5 million of tons of this enters from the land, and 1.75 tons of this is chucked into the sea directly from the fishing and shipping industry. Of this 11 million tons, around 60 to 70% is less buoyant than water, so it sinks. The remaining 40 to 30% floats, which can be carried out by ocean currents. A lot of this ends up back on shore, and only a small amount is carried offshore. Over time, this results in about 1% of all ocean plastics floating in the Great Pacific Garbage Patch, and the rest has sunk. So if you think about how much trash is in the Great Pacific Garbage Patch, majority that you can see, majority is underwater, sunk to the bottom of the deep ocean. So a common misconception is that the waste from the Great Pacific Garbage Patch is from littering, from everyday people when they go to the beach, throwing trash on the street. Ocean plastics do come from land. In the open ocean, the majority of the waste is from the fishing industry. In 2018, scientists studying the Great Pacific Garbage Patch via sampling found that by mass, around 46% of the plastics were fishing nets and ropes. This is around 60% for plastics larger than 60 centimeters. Then, in 2019, another study looked at the composition of plastics. This was done by Ocean Cleanup, a player here that will come up again and again. So they are a developer of technologies to collect ocean plastics, study and prevent ocean plastic. The Ocean Cleanup conducted this study during one of their big cleanups and published a peer-reviewed paper on the plastics that they collected. Their study revealed that 75 to 85% of plastics debris in the Great Pacific Garbage Patch originated from fishing activities. This included fishing nets, which is about 50% of all plastics, and hard plastics from things like baskets, steel traps, buoys or buoys if you're American, oyster spacers, crates, buckets, etc. In 2019, the Pacific region exported about 530 metric tons of seafood products, totaling 1.2 billion in profit. So the Pacific, this fishing region, is considered the world's most fertile fishing grounds. It produces almost half the tuna for the world. While some of this region is protected, it's extremely vulnerable to illegal fishing, with up to 1 in 5 wild-caught fish illegally caught. The 17 nations and territories of the Pacific regions control their own territorial waters as one group. These are called the Exclusive Economic Zones, or EEZs. Beyond this zone in the open ocean or high seas, this is claimed by no one. This area falls under the Western and Central Pacific Fisheries Commission, and they are charged with monitoring this space. In 2019, 81% of tuna caught in the Pacific region was in the high seas, in this unclaimed area. It was monitored by the WCPFC, and this year there was a record total of almost 3 million tons of fish caught. So, who is fishing here? The last research I can find specifically looking at the Pacific Ocean was a couple of years ago, but it found that Chinese flagged boats far outstripped any other country, with 290 boats licensed to operate versus 161 from Taiwan, 159 from the Republic of Korea. Among all companies operating on the high seas, 6 of the top 10 in total fishing effort were private companies based in China. Chinese vessels have been extensively documented engaging in illegal, unreported, and unregulated fishing. In 2022, squid fishing vessels were caught illegally fishing near Ecuador's Galapagos Island, an area that is incredibly biodiverse, that people pay a lot of money to dive, to visit, to experience the very unique and highly protected beauty of the area. So these ships were fishing in the area. They'd turned off their trackers. They then refused to let any at-sea boarding inspection, the people patrolling the area that would come onto their ships to run an inspection, which is a very normal, perfectly legal process. This resulted in a standoff between the vessels and the US Coast Guard. And instead of enabling boarding, these 3 ships sped away, one of which turned towards the Coast Guard and almost caused a collision. The Chinese government supported these vessels, claiming there was high risks of COVID, and they feared the US Coast Guard agents had guns, and they supported the vessels' move to deny boarding. Whilst we don't know what exactly happened in this case, it kind of highlights the evasive tactics that can be employed with illegal fishing fleets. And since, China has been quite reluctant to support greater patrols of the Pacific Ocean. The US Coast Guard estimates that 20 to 30% of the total global catch is attributed to illegal fishing, so around that 1 in 5 fish. These vessels are at greater risk of losing gear to avoid detection. They operate in adverse conditions like night or in storms to avoid detection, and they're less likely to access safe spaces in bad weather. Therefore, nets are more likely to get snagged and lost. If vessels spot the Coast Guard or other monitoring vessels, they may dump their gear to avoid detection or dump it to gain access to the port. So that's the high contributions of plastic pollution from the fishing industry. Why is plastic a bad thing in the first place? Especially in the ocean. So we've probably all seen the photos of the turtle with the straw in its bill, seen gruesome photos of dead seabirds decomposing with stomachs full of plastics. Harrowing images. And you may have heard also of ghost catch and how discarded fishing equipment can decimate sea life in this horrible negative feedback loop of death. But the fact is, we don't know the full extent of the impact that plastic has in the open ocean, because we don't know a great deal about the open ocean or the deep ocean, where up to 99% of this plastic is ending up as it sinks. It's very hard to assess the sheer scale of the plastic waste problem in the open ocean. It's vast. These remote areas are incredibly hard to access, and there are many species that we've yet to even identify, let alone understand their normal behavior or their health or their contribution to overall ocean health. There could be some eel that is significantly struggling with the ocean plastic that we don't know is responsible for supporting about 25% of reef species, for example, or is essential for the life of sea turtles. All these things we don't know and we might only know until it's too late. So from what we do know, at least 100,000 marine mammals die each year due to plastic entanglement and ingestion. Approximately 1 million seabirds die annually from plastic pollution, and samples of baby turtles find that 100% of them have plastic in their stomach. Ingestion is an issue. Marine life, big and small, can mistake plastic for food. As plastic doesn't degrade, they can't digest or process this material, and it can get stuck in their body and lead to a number of physical issues, including starvation, severe pain, or they can react in ways that make them more vulnerable to predators. Plastic can also be toxic, poisoning them from the inside, and this threat is so severe that a new disease has been identified in seabirds, plasticosis, where small pieces of plastic irritate the seabird's digestive system, causing scar tissue which disrupts digestion and overall health. Another issue is smothering. So especially as the plastic in the Great Pacific Garbage Patch is floating or suspended on the surface, this layer of plastic prevents nutrients and light from reaching lower levels of the water column, thus reducing the number of organisms that can survive here. So for the benthic environment, which is the bottom of the ocean, the smothering effect is also significant. And this is where up to 99% of ocean plastics are ending up. Outside of the Great Pacific Garbage Patch, this also has a significant impact on coral reefs. Marine litter deprives the photosynthetic phytoplankton in the corals from the sunlight which they need to make food. Coral reefs are super special to the ocean environments. very important to ocean health. While covering only 0.1% of the ocean floor, they support between 25 to 50% of all marine life. And I'll be speaking about coral reefs a bit more in the next episode, Per. We know from the ocean cleanup that the majority of plastics in the Great Pacific Garbage Patch is fishing nets and equipment. This is dangerous because of entanglement and ghost catch. These materials are designed to catch fish and other marine life such as octopus. So when they're discarded, they continue to catch fish. This can then attract their predators, who also then get caught, including dolphins, whales, sharks, or turtles. And turtles can, if entangled, can actually suffocate if they can't reach the surface. And this can occur indefinitely, as long as these nets remain in the water. As the plastic breaks down from these nets, they can be dispersed and be smaller and smaller pieces. This can further exacerbate the problem or entangle marine life, reducing their quality of life. You may have seen baby dolphins, baby whales becoming entangled when they're younger in some of these nets. And as they grow up, the plastic nets become more and more restrictive and starts to dig into their skin, which is horrible. Plastic can also leach toxic chemicals such as additives. These can then be ingested by plankton and then biomagnify in the food chain. These toxins impact organisms' endocrine systems, the network that releases hormones, the chemical messages in the body which regulate functions such as regulating blood sugar, metabolism, or stress responses. Where some organisms may be able to tolerate the toxins or the disruption of plastics or bioplastics in their body, their predators may not. Biomagnification is the process where the concentration or amount of a substance increases as it moves up the food chain from one organism to another. So for example, if plankton eat just 1 unit of toxin and a fish eats 100 planktons, they have 100 units of toxins in their body, and then a shark eats 100 of these fish. That shark will then have 10,000 units of toxins in its body. Pollutants from many sources can be biomagnified, and these can get into the food that humans eat. The most well-known might be mercury. Around 40% of mercury originates from coal burning, power plants, and chlorine production. This is why pregnant and breastfeeding people in the UK are advised to eat no more than 2 portions of oily fish per week. They also advise to avoid larger fish altogether, such as marlin, swordfish, and sharks. In 2018, scientists sampled UK mussels sold in UK supermarkets for microplastics. They found microplastics in all samples. And they found that 43% to 57% of debris items from coastal supermarket mussels, they were all microplastics. Then they predicted that the ingestion of 70 microplastic items per 100 grams of processed mussels by the people that ate those mussels. Mussels are benthic feeders, meaning they filter large amounts of water, so up to 300 milliliters a minute. This increases their vulnerability to changes in the ocean environment. And I love mussels. Mussels are very cool. They're an amazing source of sustainable protein. They are one of the least carbon intensive meats you can get. And they're full of vitamin B12, which we need for our endocrine systems. However, the health benefits of the B12 may be countered by the microplastics that you're ingesting. So let's talk a bit more about plastics and human health. So while we are unlikely to confuse plastics for food or become entangled, the toxics can impact our endocrine systems. So sperm counts in men have been reducing for decades, reducing by about 50% in the last 50 years. Some meta-analyses have found really strong associations with pesticides and insecticides, whilst others have found evidence microplastics also has a really strong role to play. A study in China found that found microplastics in about half of all semen samples that they took. While a 2021 study, which involved mice, they fed microplastics to mice in their water for 30 to 44 days. And they found from that significantly reduced sperm counts and higher rates of sperm deformity in the male mice. And in the female mice, they reported a decrease in ovary size, as well as a reduction in other sex hormones essential to reproduction. Finally, plastic pollution has an impact on our economy. Oceans provide an estimated $50 trillion in benefits each year in ecosystem services, such as climate regulation, tourism, recreation, provisions such as seaweed or fish, or even table salt. Yet plastic pollution threatens to strip away between $500 billion and $2.5 trillion of that value every year. This is a really great example of how action against ocean plastics can improve economics. From the Prakasam district in India, where an NGO partnered with the fishing community to remove ghost nets. So far, they've removed around 26,000 kilograms of ghost nets, as well as 5,455 kilograms of plastic pollution, and then they recycled it. From the recycling, they've earned around $16,000, whilst the fishing community has seen early signs of fish stock recovery. So this is one of many solutions that can be employed to counter the impact of ocean plastics, and I'll discuss many, many more in the next episode, where I'll shift from disaster to solutions, exploring the technologies, some of the policies, and the people working to reduce plastic waste from the fishing industry, and maybe even clean up the plastics that remain caught in the Great Pacific Garbage Patch. So I'd love to hear your thoughts, whether it's feedback on the episode, questions you'd like answered, or suggestions for the next topic that I cover. So you can reach out on Instagram at Apocalypse Nope, or by leaving a comment wherever you're listening. I'll also add some links in the show notes, as well as all the sources that I have used for this episode. Don't forget to subscribe and share and leave a comment. It helps more people find the show and join the conversation. I'm Holly Stower, this is Apocalypse No, and remember, stopping the apocalypse starts with understanding where it begins.